We'll be studying angles probably beginning Wednesday or Thursday of this week. But there are some things that you probably already know about angles. The figure shown there is an angle. It's formed by formally two rays, but in this case two segments. And this particular angle is supposed to be a right angle. We show a right angle by putting a little box in the corner. That means if we measured that with a protractor, we'd find that that's 90 degrees. We see right angles all over the place in construction. The walls of houses, the walls of rooms should be at right angles to the floors. It's easier to, they essentially balance there, and it's easier to create structures that stand up. Okay, now with regards to this figure, I'm going to change colors here, and this new segment, which connects the ends there, and I missed a little bit, so I'll cheat by just taking the end off. Now they're going to meet each other. Okay, so I formed a triangle now. This triangle has the two sides we started off, and we refer to this as a right triangle. The lines, the red lines that form the right angle, are referred to as legs of the right triangle. Let's give them lengths A and B. But what's important about this is not the letters A and B, but the fact that those are the legs, the two sides making the right angle. The third side, which is in the purplish color there, not part of the right angle itself, and we refer to that as being opposite or across from the right angle. This we're going to call the hypotenuse. Spelling is a fundamental skill. Hypotenuse of the right triangle. Okay, we're going to put the letter C on it. What's important here in what we're building up to is that it's not that it's the letter C, but it's the hypotenuse. Okay, you should know from your past a rule about the relationships between the two legs of a right triangle and the hypotenuse. The name of that rule is a pretty famous rule. It's called the Pythagorean Theorem. Right now, we're going to just accept this as being a fact that's true. Later on, in early second semester, when it's cold outside, we will prove the Pythagorean theorem, but for our purposes today, we will use it. You probably had to use it back in Algebra 1 when you took the GQE, and probably during Algebra 2 as well. But what it says is that if I take the legs and square them, a squared plus b squared, the sum of the squares of the legs is equal to the square of the hypotenuse. And that rule is our Pythagorean theorem. And what's important to remember here when you apply the Pythagorean theorem is that the letter C, which appears by itself when squared, is always the hypotenuse. It's the side that you could erase and you'd still have a right angle there. Okay, so let's look at an example of applying the Pythagorean theorem here. Suppose that we knew in a particular problem, I'll leave the C there in this example, but I'm going to change the A and the B to numbers that we actually know. So I'm going to erase the A and the B for a second. I'm going to put back in here, and I'm going to be easy on us. I'll give us some numbers that work out to a nice whole number. This is 8. Better change back to a different color. That yellow doesn't show up real well. Okay, we'll go back to red. Okay, suppose that this has a length of 8 and this has a length of 6 in some units, inches, centimeters, whatever. Then the Pythagorean theorem would say that 6 squared plus 8 squared is equal to c squared. Well, if you work these out, this will be 36 plus 64 when I do the squaring. 100 equals c squared. You should know from geometry that that will give you c. Now, in reality, it gives you plus or minus 10. But since we're dealing with a physical length here, I'm just going to write down 10 because lengths have to be positive. So the length of that segment is 10. So there's one use of the Pythagorean theorem. If you don't have this written down, you might want to pause that if you don't understand. I'm going to change the numbers now, and I'm going to work out a slightly different example. So I'm going to go ahead and erase. And this time, I'm going to erase the c. We're going to make c equal 5. That's not a very good 5. That's better. This leg will be 3. And we don't know what the other guy is. I'm going to put an x there. You might say, oh, there's no x's in the rule. Well, there doesn't have to be x's in the rule. The rule is really about a and b, which are legs, and c, which is a hypotenuse. So x is one of the legs. So we will write x squared plus 3 squared equals 5 squared. So that's going to be x plus 9 equals 25. X squared plus 9 will be 25. X squared will be 16, which means x is the square root of 16. That's going to give us our x value. I'll just write it over on the left here. X equals 4. Now again, it's plus or minus 4, but lengths have to be positive, so we're going to get 4. What we're going to use the Pythagorean theorem for in this section is to find the lengths of segments that are appearing on graphs. And so suppose we have some graph paper. Maybe I can even get lucky enough to, there's some graph paper. And on this graph we'll put a point here, and I'll call it A, and let's suppose that it has coordinates 1, 2 on my graph. Okay, so if I'm going to go, say, 3 over to the right, 1, 2, 3. That segment, well, it's 3 over to the right from 1, 2, so it would have to be 4, 2. It would have to have the same y coordinate. Some of you are going, oh, there are no coordinates there. There are no axes. Okay, so if this is at 1, 2, that means over 1 up 2, that here's my y-axis. Here's my x-axis. Now that should make you feel a little more comfortable that A is the point 1, 2. All right, now we'll put a third point C that's going to be right above B. 1, 2, 3, 4 units above it. Change back to red. Okay, here's my point C. It's going to be, it's also 4 units to the right, but it's 6 units up now. And we're going to draw in a right triangle. Here's where the Pythagorean theorem is going to come in. That's why we just talked about it. Okay, well, a couple of these distances are pretty easy to figure out. The distance from A to B, or the length of segment AB, well, that's just the distance from the point 1, 2 to the point 4, 2. They essentially are on a number line. You can just look at the distance is 1, 2, 3 units. You can count. Now, counting is fine when you can do it, but if you can't just count, you might want to notice that all we're doing really here is subtracting the x's when the y's are the same. So the length here I will show as being 4 minus 1. That length is equal to 3. Same thing we got when we counted. If we would count between B and C, we would see that the length is 1, 2, 3, 4 units. But we can also get that length of that segment BC just by subtracting. When the x's are the same, you can just subtract the y's. 6 minus 2 will give you 4. Now, if we put a variable on the length of segment AC, I'll call it C this time, I've got the Pythagorean theorem set up. I didn't draw a right angle where AB met BC, but we know on graph paper those guys should be forming right angles. So I can use the Pythagorean theorem, and this is actually one of the examples I worked on the other page. This will be 3 squared plus 4 squared equals C squared. Remember, C is the hypotenuse here, so it has to be alone. This is going to give us 25 is equal to C squared. C will be the square root of 25, which is a length of 5. So one way to find distance on a number line when the two guys aren't like A and B or B and C, they're not on a horizontal or vertical line, is to apply the Pythagorean theorem to find that length. Okay, well, the Pythagorean theorem leads us to a formula that you also may be familiar with. It's called the distance formula. Put our x and y axes there. Okay, we're not going to particularly worry too much about what these actual points are, but suppose we got a point here, and we're going to call this point x sub 1, comma, y sub 1. And that just means some x1, y1, and we don't know what it is exactly. We'll put this other point here, and I'll purposely, over here, and it will be our point x sub 2, y sub 2. We'll put our third, okay, that made a little sense, but I'm not going to do that. Sorry. This is going to be, this point over here, notice, is just as far up as the first one. So actually I did write that. I said y sub 2, but this guy actually has the same y coordinate as the first point. If I call them A and B, then A and B have the same y coordinate at the same distance up. On this graph they're both 2 up, but I'm saying in general they're both y1 units up. Okay, let's put our point C up here. Now it is x2, same distance over that x2 is. So its x-coordinate is x2. Its y-coordinate, it's up higher than the other two, so it has some different y-coordinate. Let's call it y2. We'll make our triangle. Now what we know is that A and B are on a horizontal line. Their y's are the same, so to get their distance, I can just subtract their x's. The distance here from A to B is x sub 2 minus x sub 1. The distance from B to our point C up here, their x's are the same, so I can subtract their y's, is y sub 2 minus y sub 1. Okay, if I put a variable, we'll call it C again because that's a hypotenuse out there, then I can apply the Pythagorean theorem. What I'm going to get is that, switch colors, put it up at the top here, is that C squared is equal to, well, it's equal to x sub 2 minus x sub 1 squared. Having trouble writing the squared up here. I'll have to erase that and write it lower, sorry. Okay, this is going to be C squared equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And all I've done is apply the Pythagorean theorem. Now, if I would take the square roots of both sides, I would get, and I'll write this down towards the bottom a little bigger, that c is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And c is the distance from A to the point C. This formula is known as the distance formula. Given any 2 points on a graph, we can find their distance by subtracting their x coordinates and squaring, plus subtracting their y coordinates and squaring, and then taking the square root. Okay, this is getting long. Our next video will use the distance formula.